Hi everyone. For my post, I am going to work with the letters of my name, which are C and B. And that puts me looking at a piecewise function that consists of polynomials of degree greater than or equal to 3. So the polynomial that I chose for my first piece was 2x cubed, and that's going to be what I do when x is less than 1. And then when x is greater than or equal to 1, I'm looking at the polynomial x to the fifth plus 5. And I've included a screenshot of what I produced in Desmos, but I'd like to walk through the steps of how I did that and then talk a little bit about the domain and range and whether those endpoints of this graph are either open circles or closed circles. So if I just Google for Desmos, it comes right up and I click on Graphing Calculator. And normally, you just graph something like y equals x squared and you get a beautiful parabola. But what we want to do is something a little bit more advanced. We want to graph a piecewise function. And the syntax for that is y equals curly brackets. And the first condition is that x is less than 1. And when x is less than 1, I want to look at the polynomial 2x cubed, comma. Now here comes my next condition. When x is greater than or equal to 1, I want to be looking at x to the fifth plus 5. So that did produce the piecewise function. It's a little bit awkward because the second piece of the function is hardly visible on the graph. Now you can actually click and drag this thing around, and that might be a nicer view right there. Although the problem with this is that the graph is all squished up on the left-hand side, and then I've got all this white space. So this is a bit of an art form. If you go into graph settings, which is the little wrench, you can choose your x-axis and your y-axis. So I'm going to choose like -2 to 4 for my x-axis. And then my y-axis, whatever it is set there, that looks fine. And so now I really like my graph because my function is nice and big. I can see all the interesting features of it. There's a flat spot over here. And it's not all squished up in the corner. So I've really nicely displayed my function at this point. Now you can do things like you could copy this link. You can even embed the code right into Canvas if you know HTML, or you can export the image. Lots of stuff you could do here. Now I'd like to talk a little bit about the endpoints of this graph. So down here, for the left-hand side of my graph, notice that that's a strict inequality, x less than 1. So that's actually an open circle. I don't land on that point over 1 up 2. It's an open circle. My graph gets really close to it, but it's an open circle there. And then over here at this point, over 1 up 6, that would be a closed circle. It's actually a point on the graph, 1, 6, because that is my greater than or equal to condition there on x. All right. Now, in terms of the domain is what kind of numbers can I put into the function. I can put all sorts of x values. Every x value is allowed as a legal input. There's nothing here that's going to give me trouble. So all real numbers would be my domain. And then in terms of the range, what kind of y values am I getting? Well, if I look down here, I'm getting all the negative y values. That's great. And I get 0, and I'm getting all these y values. I'm getting y up to 2. Well, I'm not actually including the 2, right? That's an open circle. So I got everything from -infinity up to open circle 2, or parenthesis 2. And then there's a break. I don't get any output for a while, and I start picking up output again. I get a signal again when y is greater than or equal to 6, and I scoot all the way up there to infinity. So, as a question for the class, I'll put that in my discussion post. Would anyone like to explore the range and looking at that notation?